guys, let's do this 2017 question from Calculus Scholarship exam. So here we have y is equals to e to the power x sine x, and we need to show that dy by dx is equals to this, and d2y dx squared, second part, we have to express the second derivative in terms of exponential and sine function only, and then find an expression for d and y. So we have to find a general solution. And evaluate this expression at x equals to 0. Right, so let's start with the equation which is given to us. Y is equals to e to the power x sine x, and we'll have to use product rule here. Product rule. Okay, so let's do that. Dy over dx will be equals to, first same differentiation of second plus second same differentiation of first. Right, so that gives us e to the power x common cos x plus sine x. Right, but this is not equals to what they're asking. So what they're asking is e to the power x sine a plus b something and square root of 2. So let's multiply and divide by square root of 2. So multiply and divide by root 2, because that is 2 to the power of half is root 2. Okay, so we're just trying to find that equation, what they're asking. So it's going to be root 2 e to the power x, and then let's have the other root 2 under the bracket. Okay, now we will expand it as 1 over root 2 cos x plus 1 over root 2 sine x. Okay, now if you are not sure, here this thing is sine a plus b, and the formula for sine a plus b is sine a cos b plus cos a sine b, and we're going to use that formula here. So let's convert that into a simplified form. So if you remember in trigonometry, 1 over root 2 is sine 45 degrees, and 1 over root 2 is also the absolute value of cos 45 degrees. So it can be written as sine pi over 4 or cos pi over 4, right? So here we can write this as, because we already have cos here, so we'll write it as sine. So sine pi over 4 cos x plus cos pi over 4 sine x. All right, so now this becomes the formula for sine a plus b. We can write it in the form that it's given in the question. 2 to the power of half ex sine, and a plus b will give us x plus pi over 4, right? And that is dy over dx, which is asked here, which is part 1, right? So we've done that. The next one says express d2y over dx squared in terms of exponential and sine functions only. So there can't be any cos function there. So we have the first derivative. Let's differentiate it again. So here we will have again product rule. So we have 2 to the power half e to the power x. First same differentiation of second is going to give us cos x plus pi over 4 plus second same, which is sine x plus pi over 4 multiplied by 2 to the power half e to the power of x. Right, again it's very similar to what we have done in step 1. 2 to the power of half e to the power of x common. We have cos x plus pi over 4 plus sine x plus pi over 4. Okay, again multiplying and dividing by root 2. So again, so we can have root 2 here, we can convert it in the same formula that we have used before. So it's going to give us d2y over dx squared as 2 root 2 e to the power x, and we are multiplying with again another 2 root 2 or square root of 2, and it's going to give us 1 over root 2 cos x plus pi over 4 plus 1 over root 2 sine x plus pi over 4, and that gives us 2 root 2 half is going to give us 2 e to the power of x. This leaves us with sine pi over 4 cos x plus pi over 4 plus sine is already there, cos pi over 4 sine x plus pi over 4. Right, so that gives us 2 e to the power of x sine x plus pi over 4 plus pi over 4 is 2 pi over 4. All right, and this is d2y over dx squared. All right, so now if we see, so if we have to generalize now, we will see dy over dx and d2y over dx here, and see if we can create a pattern to generalize it. Right? So we have dy over dx, d2y over dx, dny over dx to the power of n. Here it's 2 to the power of half, here we have 2. And 2 can also be written as 2 times 2 half. Right? 2 times half. So n times 2 to the power of n. So it becomes 2 to the power n times half is n over 2. Right? So that is 2 over 2. E to the power of x. E to the power of all. Then we have sine. So it's sine x plus here. It was 1 here, and then 2. So it's sine pi over 4. Right? So that is the generalized formula. Now at x is equal to 0, we will have dny over dx to the power of n is equal to, just x is 0, n is not 0, alright? So it's e to the power of n over 2, e to the power of 0, sine 0 plus n pi over 4. That will give us dny over dxn is equal to e to the power of n over 2, e to the power of 0 is 1,